Hey everyone, my name is Trent Kelly, and this is my first attempt at D211, and I'm currently studying for my master's degree in data analytics through WGU. And the presentation I'm about to see is covering 3 total data sets. One of them is the WGU medical data set, and then 2 data sets from the National Health Institute. And those 2 data sets primarily cover your demographics, so things you would expect: age, gender, education, and then also a questionnaire primarily centered around diabetes that focuses on diabetes and comorbidities and other factors that coincide with being diabetic. And through this analysis, when the key findings, so when looking at the comorbidities, I focus on high blood pressure this time around, and it's difficult to trust the data that we got, and I will illustrate why in just a moment. So I'd really like to understand the questioning methodology employed by WGU, and it would also be nice to know with the National Health Institute as well. And so basically just wanting to know how the information was reported. That way we understand if there's any influencing happening with that. And the actionable insight that we have, based on our findings, we have a severe discrepancy between our data and the National Health Institute's data. So I'd recommend reviewing how these metrics are captured. Are we getting high blood pressure off of patients and that's going into the database? Are these questions like they are with the National Health Institute? How is this information being obtained? And if we know how the information is being obtained, we will be able to be better equipped in analyzing this data. Then beyond that, identified that the largest demographic represented in both data sets are going to be both male and female. They are pretty much split down the middle-aged, and have 0 to 1 kids. All right, so here's the actual analysis portion. And so the things that I wanted to focus on are the high blood pressure of WGU's data set, and then the blood pressure of the National Health Institute. And then I also want to look at the average age per child per total responses. So this gives us some KPIs and also some demographic information on the patients that we're analyzing. And so starting out with WGU, we have a large number of positives being reported. The one downside is with the National Health Institute, there's 151 reported positives, but there is a large number of people that just did not respond to this. So it's hard to directly compare. But what we can take from this is that with the WGU numbers, there are a lot of both responses, negatively and positively. And so where is this coming from, and how was it obtained? Again, is it the doctors and nurses that are collecting the blood pressure and then inputting this into the database? Is this a questionnaire that's going out? I would feel more comfortable acting on this portion of the analysis if I knew how that information was obtained. And further, this splits it out between male and female. And then we have our percentages. So we have 48.34% of positives with WGU. And then we have about 2.5% with the National Health Institute. And so when we come down here and look at the average age per child, that should actually be changed. see if I can change this in real time. There you are. There we go. There we go. That wasn't showing the average age earlier. That was showing the counts. And so again, this is showing the child per average age, and this gives us the amount of children down here and the total number of responses over here. This is split by gender. Blue for both is male, and amber is female. And I have these sliders here just to help us visually. So this will show us male, female, and it shows for both WGU data sets. And the same thing for the National Health Institute. If we want to drill down specifically on male or female, or look at them in aggregate, there's that function. So that concludes the analysis portion utilizing Tableau. I did want to show my data source. This is how I connected all of them. This will make more sense when I show the actual SQL portion or SQL portion, how I have everything connected. And this is also part of my referential integrity. I created 4 temporary tables to use, so I was not inputting anything directly into the database itself. So nothing with the existing internal database was being altered. I pulled the information out that I needed, and I created 4 separate tables that I can connect in Tableau to maintain that referential integrity. And okay, we're still recording. All right, so we'll just start everything over. So that's going to drop everything and drop if exists. And this would be nice to do or run or have at the top of your query, because if this is on like a loop or anything like that, if somebody is using these queries over and over again, you may get errors. If you're just running it, if the database already has these tables, it will be halted. So it's a little bit of error mitigation. So the first table we're doing is the demographics table, which this is the National Health Institute data. And so I've assigned them all numeric data types. Okay, successful. This is the questionnaire table, and just we'll change those later, but they're assigned a data type of numeric. And this is going to pull in the information from the CSV files to fill those tables, because we just created blank tables with columns. So this will fill those rows, and make sure that we have everything we need for question. And this table just has a lot of nulls. There'll be some 17s floating around. Yeah, there's one. Okay, demographics looks good. All right, we're going to start changing the names. This is based on the National Health Institute Data Dictionary. So changing it to diabetes, children, age, gender, and we're creating a new table, diabetes WGU from services add-on. We're just pulling the diabetes column out of there, making a new table. And so with the question table, we're setting the high blood pressure because it had 17. We're going to change it to 1. Anything else is going to be a 2. And we apparently haven't created it yet, so we will come back to that one. And so this is diabetes WGU, just changing it to a binary value. And that should have actually been created. Where is it? There it is. There we go. I must have skipped over it. And alter table, so we're just adding a column, W to diabetes WGU, diabetes underscore WGU. And then we're going to fill that column with the information from the diabetes column and using a numeric data type. And then since we have this new one, diabetes underscore WGU, because historically diabetes was text because it was male and female, and I changed it to binary, but it doesn't automatically update it to like integer or numeric since I put everything else as numeric. With the other columns, I made this one numeric as well. And since we have that, we're just going to drop the diabetes column. Let's take a look. Okay, terrific. Creating a new table, patient underscore WGU, and we're pulling these 4 columns from the patient table in the existing database. Okay, make sure it all pulled. All right, so you can see we have gender and high blood. These need to be changed to binary. So that's what this is for gender. And for high blood pressure. Okay, let's make sure that worked. Okay, now I have binary values. So then we're going to go in and alter the table and put in a new column, gender underscore WGU, because right now it is text. We want it numeric. So we're going to add that column. And do the same with high blood pressure. We're going to add that. And we're going to update, fill that with the data from the high blood pressure from the patient database. And same thing with age. Oh, I forgot the whole thing. Create. So I created this table because I was reading the data dictionary and I noticed that the way that the National Health Institute has that is anything over 80, they just lump into 80. So I made this table so we can keep everything between 18 and 80. And so I had to do 2 things. So the National Health Institute, it had younger ages, but the WGU data set started at 18. So I selected from the National Health Institute starting at 18 to 80. So that's what this is. It already exists. That may not be in my drop table. No, so it exists because it's not in my drop table up here. So all I'd have to do is just drop it, and then that would run. And just so I don't get dinged on it. I'll just go ahead and do it. All right, and add age column for numeric, and then we're going to fill it just like we did before. We're going to drop the old one. And then with the patient WG1, so anything greater than 80, it's just going to pump it back into 80, and that will be in line with the National Health Institute. And so that's what that does. And that concludes the SQL code, which will be included for further analysis. So let's see what else we got. Describe the technical environment used to create the dashboards. So we went over that. That's with Tableau and pgAdmin. We did demonstrate the functionality of the dashboards, explain the scripts used to support the creation of dashboards, which we just did. Explain how data streams were prepared to support the analysis. That was done by showing how they work in Tableau, how they're connected. And so when you bring one of these in, you have to select a column that they relate to. So the diabetes column was connected to the diabetes column in question. And then with question, there's an age column, which is connected to the age, and same thing with patient. So that's how the data stream works once it's imported into Tableau. All right, so, and describe how data were aligned with other data points. So the data from the existing database was aligned with the National Health Institute's data by looking at like diabetes, high blood pressure, age, gender, those things, those types of things. And from there, they were just used with total counts to compare like the big picture of the data set based on the metric we were looking at. Demonstrate how the databases were created, which I believe we just did sufficiently. Explain how referential integrity was enforced in the database. So I did talk about that earlier. So I didn't use any primary or foreign keys with this because it was difficult for me to, like typically you'd have a primary key like a customer ID or something like that, and then you could only have one primary key, and then that foreign key on another table would relate some way to the customer ID. And with since I was using a total of 4 different tables, I felt that it was easier just to maintain that referential integrity by making temporary tables. That way the existing database was left unaltered. There was no direct manipulation, or well, not manipulation, there's no direct alteration to the existing database. So there was no damage, the integrity was left intact. And then from there, a sort of referential integrity was employed by this, by linking them together with the appropriate and respective columns. And you have the report included, so that looks like it's everything that this is asking for. So I appreciate everybody's time and hope you have a good night.